I recently ran a webinar to my members, and today I'm giving it away for free. It's all about how to use arrays to optimize your VBA code. Now, if your VBA code is slow, it's often because you're using ranges to process your data. Now, arrays let you move the data into memory, then process it there, and then send it back. And this is dramatically faster than using ranges. So we'll start with the basics of using arrays, and then we'll build it all the way up to some advanced techniques. So let's jump right in. So let's imagine that someone comes to us and they say they have one student and they want us to write an application. So very simple application. And what it does is it reads a value from A1 and it takes that value and it writes it to D1. Now, in between, we want to do something with that value. We want to multiply it by 10. So how would we go about writing the code? Now, what we do first of all is we would declare a variable. So we declare a variable as a long integer, and then we would read the value from the worksheet. So here I have sh marks, and this is what we call a worksheet object. So if we look over in the window on the left, what you'll see is that we have the name of our worksheets, and we've got a name in the parentheses and outside. So the name in the parentheses is the actual worksheet name, and that's the name you'll see on the bottom of the worksheet. Now the name to the left of the parentheses is what we call the code name, and we can change that under the properties here. Now the advantage is if someone comes along and changes the worksheet name, then it doesn't affect us, the code will still work. And we can also use this code name directly in the code, just like this. So once we have this, what we do is we get the range. So the range we have is A1, and then we say value. And so this will write the value to our marks. So the second thing that we want to do then is we want to do something with our marks. So we want to multiply it by 10. And then finally, we're going to write it back out to the worksheet. We're going to write it out to D1, and so we write it out like this. So very simple terms, this is what we do in most VBA applications. So we read data, we process that data in some way, and then finally we write it out. So it's very important to think about VBA applications like this, because anytime you're building one, you're going to be doing it some way like this, and it's always good to split it into these kind of three different things to separate them. So that's all good, and let's run the code just to see that it actually works. So we run our code, and you see that it wrote it out. So no major surprise there. So what happens now is that our customers come along and they say to us, you know something, I now have 2 more students and I'd like to have your application work for those. Now what we could do is we could update the code. So we don't know much about programming, so we'll just add a line for each one of those new people. So let me just copy and paste that in rather than writing it all out. And we'd update it and our code would look like this. So now we've got one line. Every time we've got a new student, we have to declare, we have to assign, we have to process the data, and then we have to write it out. Now this doesn't make any sense, because if we had 1,000 students, then we'd have 4,000 lines of code. And the second major problem is that if each day or each time that we're dealing with students, we could have a different number. And so say one day we have 5, the next day we have 100. Well, then our code can't cope with that. We've got to just keep changing the code. So obviously this makes writing code like that very impractical. And that's where arrays come in. So what arrays allow us to do is kind of treat the variables as one variable. So treating all these variables as if they were one. And how we would do that is we declare an array like this. So we say dim1, 2, 3, and then we don't need this line here. So the important thing then to understand is that when we're using arrays, arrays are powerful in that we can access something using the index, but what really makes them powerful is the fact that we can use a for loop with them. And the for loop allows us to repeat lines of code like we have here, but just to write the line once and then have it repeat and work slightly different. Now, before we get to the for loop, I'll just show you what this code would look like if we just changed it to work with the array. So it's important just to understand that. So we replace all this, then we replace all 2, and then we replace the third one. And now if you look at the code here, you'll see like it looks pretty much the same, but the difference is that we're using an index instead of using the actual name of the variable. So that gives us the flexibility. And now we can just put in a for loop. So we can say dim I as long, and we can say for I equals 1, 2, 3. And then we only need one line ever to read the marks. So we're basically going to say I here. And what we put in here is we put an ampersand I. So what ampersand I does, it basically, the first time I will be 1. And the ampersand basically converts it to a string and then appends it to A. So we get A1 the first time, A2 the second time, and so on. So we can also add a for loop here. And then we get rid of these lines. And finally, we can add it to the last part as well. And now we have all the code, and it doesn't matter how many times or how many students there is, the code won't expand any further. So this has solved one of the problems that we have. Now, of course, one of the problems that we have is that's still left is that if someone changes the number of students, so say the number of students tomorrow is 5, or say we run it on multiple classes with different numbers of students, each time we run it, we've got to go and change these numbers everywhere. Now, one thing we can do is we can use L-bound. So there's not many functions in VBA for arrays, unfortunately. But this is one. But L-bound and U-bound are 2 that do exist, and they basically give us the first position and the last position. And the beauty of this is that once we get an array, we don't have to worry how the array was created or if it starts at 0 or 1. We just use these, and then we know automatically that we'll get the right size. So this has got rid of the problem, or made the problem a bit smaller, in that now we only have to change in one position. So we're getting better all the time. So let's just run the code just to ensure that what we have is actually correct. And when we run the code, you can see that in D, the column D, that it wrote it out. So all good. So what I'm going to just put in here is one line, and this will just clear that. So it'll just clear what's in column D. And the reason for that is just so that we know that the data has been cleared every time, and that we're not left with legacy data from before. Now I'm going to change. I'm going to explain current region in a while, but for the moment, just trust me that it works. Current region, and that should be clear contents. So everything we have, it's all working fine, but the problem, of course, is that we've got to change this number every time. So if I want that to run with 5, I've got to change it. So that's not practical, because we want our code to be autonomous. We want it to work automatically without us having to make changes like that. So what we do is we come along and we use what's called last row. So last row, we're going to declare as a long integer, and we want to assign this to the last row of our current column. So how we do it is we basically go to the end of our spreadsheet like this. So this is the last cell in column A, and we press the End key and the up arrow. So we press End, up arrow. Hold on, let me do that again. End, up, and that brings us up to the first cell that it finds with data. So if I data in cell 9 here, and I'll do end and down arrow. If I do end and up arrow, it goes straight up and it finds the last row with data. So we're going to use that in the code. And the way we use it is we say the sheet and we want to go to the last cell. So to get to the last cell, it's column 1 and the row is the last row. So to get the last row, we basically do marks rows.count. So now that gives us the last cell, and then we do end to use end, and we use XL up, which means we're using the arrow key with it. And this will give us back a cell, and we just want the row of that cell. Now, if that seems a bit long-winded and complicated, that's because it is. But you basically, anytime you're using last row, you basically use it like this. So you don't need to really figure it out every time. It's always going to be like this. And now we can use last row in our code. So we can say, I want to put last row here. Now there's one little problem is that dim doesn't allow us to have constants in it. So if I do a debug compile, it complains. It says it must be constant. So whatever you put in your dim statement must be a constant value. You can't put in variables. And the reason for that is because dim basically declares the variables, and it's all done before the code actually runs. So it's the first thing that happens. So there's no way that if you declare a variable, the variable won't have been filled with any data. So it just wouldn't make sense. So we use what's called redim, and redim is a line we can use anywhere in the code. So it doesn't have to be just after the dim, but anywhere in the code. And this basically it's redimension is what it says, but what it's basically doing is setting the size of our array. So in our dim line, we basically say, I'm creating an array, but I'm not going to tell you the size yet. I'm going to tell you the size later. So that gives us flexibility, and then we can just redim it. Now we don't need to say as long here if we don't want to. And then based on how many different students we have, it will automatically figure it out. So if I go up here, and let me just drag this down, and let's run the code. So you'll see that it figured out that there was 5. If I go back to 2, for example, and I run the code, it figures out that there's 2. So this is pretty good in that it's solved those problems that we have, and the code is now it's flexible. It's pretty flexible in that it can handle the different types of the different numbers of data. But of course, we haven't solved all our problems. So the problem that this code has is that if we look here, we're reading from the range, and if we look here, we're writing to the range. Now that's fine in a small application like this, where we're just doing like a handful of kind of different pieces of data. But imagine you have code where there's 100,000 pieces of data. Well, then what happens is you start to run into problems. So every time you access a range, you've got to think of it like you're going down a dirt road. It's slow and it's inefficient. Whereas every time that you're accessing an array, it's much faster. So if you're dealing with hundreds of thousands of pieces of data and you're just accessing them in the range all the time, it can take it varies depending on what you're doing, but it could take a half an hour to run. It can take hours to run. I've heard of people with 4 hours, and I even worked in a place where someone wrote one thing really badly. It was running like overnight. So what we want to do is we want to take the data from the worksheet. We want to write it straight to the array, and then when it's in the array, what we want to do is we want to process it, do whatever we want to do in the array because it's fast, and then when we're finished, we write it back to the worksheet. So we're just doing 2 things. We're doing worksheet to array, and then we're doing array to worksheet at the end. And that means we've only 2 journeys, and they're the 2 journeys like that will be slow. So let's upgrade this code again. So imagine that there was a better way of putting all this in than reading through the range and copying everything. So imagine that there was a better way to do it. And the thing is, there actually is a really cool way to do it in VBA. So what we do is we put marks and we make marks be a variant. So a variant variable in VBA, this means we're basically telling VBA, we're not going to say when we don't know actually before the code runs what it's going to be, but when the code is running, we'll let you know the type. Now, in general, that's a poor practice. We like to kind of specify the type so that VBA will pick up the errors if we do use the wrong type for the wrong thing. But in this case, we have to use the variant, and it's well worth using it because the result is quite good. We can say marks equals to, and we can say a ampersand, and we can say we want to read from A1 to a ampersand and last row. So that's the range we want to read. And now we don't need this, and we don't need this. So we don't need this loop anymore. And we can copy this down to here. And if I go back to my worksheet and I run the code, give me a subscript out of range. So just before we look at that error, we'll look at the locals window. So if we look in the locals window, so locals window is like the watch window. They're kind of very similar. The difference is the locals window gives us the variables that are in play at the moment and shows us their value, but it's read only, so we can't change it. But it's very useful if you just want to look at the variables that are there. The watch window, on the other hand, isn't read only, but we have to put the variables we want into it. But the advantage of the watch window is that we can do a lot of configuration. So we could we could pick a specific thing in marks, we could multiply it and so on. But anyway, before we go any further, let's have a look at marks. And you can see we've got marks 1,1 is 85 and marks 2,1 is 10. So what this means essentially is that when we read an array from the range, it's a two-dimensional array. So let's get rid of this. And what we've been dealing with up to now is one-dimensional. So if you're ever confused about one-dimensional and two-dimensional, as a lot of people are, I'm just going to explain it very simply. One-dimensional array is simply an array that's a list, like the one we were using. And think of it like a row. So it's just got one row of data. A two-dimensional array is an array that's got rows and columns. So basically a spreadsheet. So that is essentially the difference between one-dimensional and two-dimensional. Now in programming, you can have three-dimensional, four-dimensional, but they're extremely rare to go beyond two-dimensional. If you're writing something in Excel VBA and it is three-dimensional, then you should really question what you're doing. You're definitely doing something wrong. Now going back to our code here, so the reason that we have an error here is because it's a two-dimensional array and we've only given it one dimension. So it's like if I said to you, I want you to change something in a cell, you'd say, well, what's the cell? And I'd say, well, the cell A. And you'd say, yeah, but A, what's the column? You've given me the row, but what's the column? So here we've got row I, we've got to say the column is also, or the column is 1. So we've got to say what the column is. And then we'll run the code on further, and you can see that it works just as well. But the difference is that we can't obviously see because we don't have a lot of data, but this is a much faster way to do it. Now, obviously, we wrote it out, or we read it in. We can also write it back the same way, which is also very useful. So we can say, we just make this look marks, and we say D1 and ampersand last row. And then if we run that again, so let me just drag this down. And you can see that it worked just as we expected. And our code is just a little bit neater. So the next thing that I'll do, and I'm just going to do the sales data, and I think I'll do the upgrade here, copying the range. So if we're dealing with dynamic data, so the problem that we have is every time the data changes. So what we want to use something a little bit better than last row. And what we can use is actually what's called current region. And the way it works is we give the range and we basically say, give me the current region from that range. So the current region in simple terms, now you can see the current region if you use control and asterisk. If you use control and asterisk, so control shift 8 on a lot of keyboards, or control asterisk on your number pad. And what it does is it basically gives you all the adjacent data. But it's really useful if you're using records. So if you've got a list of records like we have here in sales, anywhere here that you do control shift 8, control asterisk, you will get all the adjacent data. So the current region is very useful. So it gives us all the adjacent data. Now so we don't need last row anymore then, and we can get rid of this. And the next thing is, when we're writing the data, here we're depending on last row. And so the problem with this is that in this code, any time that we're writing out, we need to always be passing that variable last row around. And that's not really feasible. What makes much more sense is that if the person looks at the array, so you give it an array to write out, and it looks at the array and says, what size is the array? I'm going to write out that array to the range. So that makes much more sense. And how we do that is we basically do a resize. So I'm going to write out to D1. That's what I want to write out to, but I want to resize it. And we resize it to a row count and a column count. Now I'm just going to put this down here. So you can see that I was using current region here to give me all the adjacent records, and then it clears the contents. Now, so we have column count and row count, and we want to get them. And so column count and row count are basically just going to be the row count and column count of the array. Now I could do it right here, but it's just neater to do it like this, and we'll be making this code even better in a while. And so what we do is we say row count, and row count equals ubound. Now let me just bring this code up a bit so that's centered on the screen. So we can say ubound marks. Now I was using ubound marks like this. And ubound marks like this means the first dimension. So it's the highest position in the first dimension. So in other words, it's the number of rows. Now we can use 1 like this. The default is 1, so you don't have to use it. But I'm just going to use it like this to be clear. Now most of the time you will get away with using ubound like this, because if we're dealing with a range, our array is always going to start at position 1, but we can't be guaranteed that. So just for safety's sake, we should do it the right way. So we should say ubound minus lbound. So the first position the last position minus the first position plus 1. Now just in case this doesn't make any sense, let me just explain it. Imagine our array goes 1, 2, 5. So we're saying the size of that is 5, obviously. So we're saying it's 5 minus 1 plus 1, and that will equal to 5. Now imagine our array is going from 0 to 4, which still is 5 positions. Well, it's starting at position 0. So if we use ubound, it's actually wrong. So when we use this calculation, it is 4 minus 1, 4 minus 0 actually, and plus 1, which is 5. So in both cases, it gives us the right answer. Now I'm going to be cleaning up all this code later, so it'll be neater. But it's just important to understand all these concepts. And the column count is basically done the same way, except we use 2 here. So 2 means it's the second dimension, or the columns. And then all we've left to do is run the code. So we'll do a debug compile, make sure everything is okay. And let's delete this. I know it'll delete it anyway, but I just like to be just for illustration. It just looks better, and we run it, and it runs fine. So the advantage again in this code is that it's using current region to get us all the adjacent data, and it's using a resize here to figure out the size of the array. So this code will work in a lot of cases, which is pretty good, because what we want to do now is a more real world example than just the simple numbers. So here we've got sales, and what we want to do is something similar. We want to read all these records, and we want to multiply the amount by 10, and we want to write it all out here. Now let me get rid of Copilot here. And so what I'm going to do is I'm going to actually copy. So this code is so kind of good. It's, you know, it's so useful and so kind of that it can be used in so many places that I'm going to copy this code and I'm just going to paste it in here. And you'll see that it doesn't require many changes to get it to work. So because I'm being consistent in my naming, I can actually replace marks with sales. And that should work in most cases. I don't get any errors. And so what I have wanting to be careful of here is that this should be F1 and this one should be F2. And this one, now we'll have a look at this in a moment. I'm going to do current region then offset by 1. And we'll see in a minute exactly what that means. Let's save this and let's run the code and see if it all goes according to plan. And we've got a type mismatch. And the reason for that is because I just didn't update the so I just didn't update the sorry, let me just put the chat back on. So I just didn't update the column. So the column that I'm using should be column 4 rather than column 1. Now, actually, sorry, it takes me to the next point. So it should actually be column 4. But the reason that I'm having the error here, and this takes me to the next point, is that what we want to do is we want to avoid reading the header. So we could start at 2, but the problem is if we start at 2, then hold on, sorry, let me just my winning there. The problem is that if we start at using that 2, then what we're basically doing is we're starting with a range that is the wrong size, and then we're just kind of working all around it. And so it's much better to get the range that we want. So to get the range that we want, we have to kind of play around a little bit. So what we do is we do dim RG as range. And again, I'm going to be cleaning up the code, so don't panic if it seems a bit crazy. So we set the range equal to the current region as we did before. And now what we want to do is we change our range. So if you look here, you can see that our range, so our current region will get us all this data. And the problem with this is that we have the header. So to get off the header, we just move down 1 row. So we offset the range by 1 row, and that will give us this. So how we do that in the code is simply offset by 1 row. So that gives us a new range then that we can see. But of course, we have a blank line at the end. And so we want to resize our range to the current size minus 1 row. And so we use resize. And the size of the ranges is range.rows.count. And we want size to be minus 1. And then from that, we want to get the value. So if we run the code on, it won't work, obviously, because I have to start it again. So all space R. Sorry if you heard that Evil Knievel driving past me there. So sometimes there's just loud motorbikes outside. I think it just seem to be around a lot in the summer. Now we run the code, and you can see that it worked just as we expected. So we took the code that we'd already refined and we used it here, and it worked with very little changes. We just have to change the column, and we just updated it to deal with the header. Now I often get asked, the data I have here is in a table, and tables are great. And if you can use a table, then I'd always use a table. But I just want to write the code because you can't always have a table. But just supposing you wanted to get the data from the table, then it's actually really easy to do that. You basically do sheet and you do marks. And so what you do here is you get the table name. So the table name, if you click on the table, under table design, you can see that it's TB sales. And we do list objects. And then that gives us the table, and all we have to do is data body range, and that will give us the data. We don't have to do any of this messing, cutting it off or anything like this. But don't worry, we're going to fix that anyway in a few minutes. So that code here, a bit messy, you might say, but because we're using this code all the time. So every time we're like writing code, we're going to use this. Why not write functions that will do it for us and make our code that bit neater? So in here, you'll see that I've written get current region, and that's just a really simple sub that's basically doing what we're doing outside, but it's just that we can call it and it will hide the messy code. So we go back here in the sales example actually, and I will just do sales equals get current region. And if I do get current region, then all I have to do is pass it the range, and the range is this one. And then we have a second optional parameter, and the optional parameter is the header size. So sometimes your header size might be more than one. So that's often the case where you get data and you've got like a header size, maybe it's 3. And if you do a current region, it's going to get that. So by changing this to whatever, you can say, okay, I don't want to top 3 rows. But anyway, in our case, it's just 1, so we don't even need the default. And then we just put the value. So that's going to get us back down, and that's the value. So we don't actually need this, and we don't need this. And of course, it's always prudent to check that the code actually works. Now, of course, as I said, I'm sorry, this is just jumping onto my other screen. So as I said, so it's always good. I know I'm deleting this and it's rewriting it, but I'm always a bit paranoid. So let me just run it just to make sure. And there you can see that it still works fine, but the code is a bit neater. Now let me just put the window back there. Control R, by the way, is for the project window, and the properties window is F4. If they ever disappear, you can find them under view anyway. They're both here. So let's get rid of this guy and this guy and this guy. So you see the code is that bit neater. Now down here, this is, it's a lot of code. It's the same every time, but it's a lot of code. Imagine you could just do all this in one simple function, and that would be array to range. Now it might look a little bit complicated, and that's because it is a little bit complicated, but really what I have here is 4 optional parameters that you don't need to use, and they're just in the case that if you want to specify the number of rows, so you don't want all the rows in an array, then you can just specify the number of rows and the number of columns, and you can specify the header size again, or if you don't even want one. So we can replace all this code by just saying, we push it up the screen so that everyone can see it. And what we do is we do call. A call is optional, but I really like using it. It just makes the code, I think, a bit clearer. It makes it easier to see the calls that you're using. And what we want to do is array to range. And our array to range, we give it the actual array, which is sales, and the first cell that we want to write to. So the first cell that we want to write to is going to be sheet F2. And all the other things, it'll delete the first row by default. Let's do Alt FC, and we do debug compile Alt space R, which should put me back over here. And here we are. Just see who's talking about these other plans. Yeah, I don't know who's writing these things about other plans in the chat, but you can just ignore them. So where was I? So yeah, if we just run the code now, and you can see that it works just as we expected. Now the beauty is this code from what we started with, like we can see how powerful the code is now. And let's get rid of all this. So everything we're doing in our code is basically we're reading the data, we're writing the data out, and then somewhere in between we're processing. So in a lot of applications that you use in VBA, you'll actually can just use this to get your data, use this to write your data to a range, and then in between you've just got to process your data, which is normally where the complicated stuff happens. But when you're writing an application, knowing that you've got this out of the way and this out of the way, makes things a lot easier. Okay, so this takes me to then, let me go back to my PowerPoint for a second. And not that PowerPoint. And so in VBA, or in any kind of data that we're using, so VBA, of course, but in anything, we've got three main data operations, and it's good to kind of have them in your mind. So select records based on criteria, which is a filter. So I've said where there. So where is what we'd use if you're using SQL. So it's a where statement. So that's selecting records based on a criteria, that's filtering. So the group and sum. So in SQL, if we were using that, it would be group. And so group and sum is like group by, it's the new function in Excel, or it's like a pivot table if you're not familiar. So it's like we take the salespeople and we want to get the totals for each salesperson. So we would group all their amounts together, and we would have one entry for that person. So that's the second one. And the third one then, the third type of operation, is what we call get data from multiple tables. So this is what we call a join. So if you know anything about SQL, you'll have seen left joins, inner joins, and all this. And that's like if we were writing a report on the salesperson, and on the report we wanted details about them. So it might be like we wanted to have like their phone number, or maybe the city they were based, or something like that in the report. So we go to the salesperson table to get that data. So we'd be joining data from two tables. So these are the three things that form all your data operations, and it's important to kind of keep them in mind, or to understand. So I'm going to look at the first one now, and that's filtering data. So filtering using an array. Now there's lots of ways to filter in VBA, but typically what I find is that when someone's writing a real world project, it can be a complicated filter where they're looking at lots of different things on a particular line, and so it's not something that they can do kind of simply. They go through each line and they evaluate stuff, and then they do their filter based on that. But we're going to do our filter anyway, just to show you exactly how we would do it. And we can use this code as the basis for our filtering. So what we will do is we will come to here and we will say if sales I, 2, and let me just double check that's right. So that's the salesperson is column 2. We want to say if they match the person in row K. So I'm going to put Bill in row K here, and what our application is going to do, it's going to reach all these records, and if it matches Bill, it's going to put Bill here, and it's going to put the next Bill here, and so on. And the output will be all the bills. So it's very important to understand how to do that in using an array. So we're saying if the sales I2 equals salesperson, then we want to do some kind of copy. So we want to copy the data, and we want to write it out. So the salesperson will be, we'll just do it up here. We'll do stim salesperson as a string, and we'll assign that salesperson, and it's going to be sheet sales dot range and K1. Now in VBA, we can join two lines together using a colon, and it's often just used with dim lines. And I'm just doing it here just so that we can fit more on the screen. So it's a personal choice, really. It doesn't change any functionality, but if you like, if you want to do it, you can use it in your code. So now we've got the salesperson, and if the salesperson matches, I want to write it out. So what I'm going to do first of all is do a debug print, which writes to the immediate window. So we're going to print out the salesperson if we match them, and we're going to print out their amount. So this will just know that the logic of our application is working. And we look in the immediate window. So the immediate window is under, like all the windows, it's under view. view immediate window, or Control G is the shortcut key. So let's run our code. Now, I actually didn't want this to be writing out, but we run our code, and you can see that it writes out bill. So bill is 850, 252, 246, 702, and so on. So that's all the values for bill. We can just double check. So 850 here, 252, and so on. Now let me I just actually got rid of all the format here. Just put it back. And so we want to copy our row now. So somehow we want to take the current row and copy it. And the way we do it is we copy it column by column. So we use J as long, and we want to read through that row and copy it. So we'll say for J equals, and like L-bound sales, so L-bound sales is the row, we want to do it on the column. So we want to read through the current column, and we want to copy. And it's going to, whatever we're assigning, it's going to equal sales ij. So I the current row and j the current column. And we're going to be copying this. So what we need to do is create a second array, and the second array is going to have our results. Now we don't know in advance the size of the second array. If we do know, we can redim, but in many cases we don't. So what we do is we just set the array to be the size of the sales array, and then we just write out the values that we need. Now, if we're dealing with a lot of data, it might be efficient, so we might come up with a kind of a different way of doing it. But for something that doesn't have a huge amount of data, it's not a problem. So I'm going to call this output array. And so output array something j. So it's going to be that field. We're going to read through the row. We don't know the row in the output array yet, and we're going to copy all the data. The first thing we do then is declare the output array as a variant, and we redim it. So we set the size of it, and we want to set the size of it to the sales. Now I'm going to do this as it looks a bit, it's simple, but it looks a bit long-winded. So let me just put this to 1 as well, just for clarity. So I want the output array to have the same number of rows and the same number of columns. Now I did the underscore I do here, space underscore allows you to split up a long line over multiple lines, and it's useful at times, especially if you have lots of parameters. And this has to be 2, and I need a comma here. And so that's our output array. And when we're writing it out, we're just going to write out our output array here. We don't need to do anything else. Just in our array to range, we just basically say this is our output array, and can you write it out for us? And it will figure out how to write it out. Now, one thing we will need to change, but we'll come to that in a moment. So we need to figure out the row. So what we need is basically just a variable to track the row. So let me just explain that. Current row as long. So when we're dealing with Bill, we come here, and so this is the first row. So I is 1, and then we go here, I is 2, and I is 3. But when we get to Bill, I is 2. But we're going to write this out as row 1. So the first Bill is row 1. But now when we get to the second Bill, this is row 4 in the original data. But when we write it out, it's going to be row 2. So we need something to track that output row. So I'm calling it current row. I could call it output row. I'll call it output row just in case it makes it a bit clearer. So output row is long. And what happens is if we find the salesperson, then we add 1 to it. And this is how we add 1 to it in VBA or in most programming languages. And then we put it here. So this line, these lines here are basically just running through every item in the column and copying to the given row. And we do a debug compile, all looks good. And let's pop it across here. And let's run the code. Now I've got a subscript out of range. And the reason for that is because this should be 2. Now, so what subscript out of range means, if you ever see it, is that you're basically trying to put something in a position that doesn't exist. So for example, if we had an array that's 1 to 5, say, and we try and put something in position 0 or position 6, that's subscript out of range. So that's essentially what it is. The same with like a collection or a worksheet collection. If we try to access something, say we use sheet 1 and there is no sheet 1, or we've changed the name, then that gives us a subscript out of range as well. So let's stop that and let's run the code again. Yeah, so if you're using arrays, you're going to see subscript out of range a lot, but don't panic. It's actually pretty straightforward. And there you can see it wrote out all the data as we expected. So if we change our data now, and we're going to make it Mary, and then we run it, you can see that the code is very flexible. It adjusts to the different person. So let's clean up this code again, because as we can see, it is a bit messy. Now this one here, output array, you know, it's not the end of the world that we write it like this, but it's still long and messy, and it'd be nicer to have just a nicer way to write it, a smaller one. So array set size. Array set size, really simple. It's just basically doing that. But we'll do call array set size, and we'll say the destination array is output array, and the source array is sales, obviously, and that will do that will set the size. Now the other one is copy row, and that's very useful because you use it a lot if you're dealing with arrays. And that's this one here. And basically it's just doing the same thing. It's just the for loop here. Now with these procedures, you tend to, as you write them, you'll put in like this, and this is basically just checking for errors. It's basically just saying if there's an error, create an error. So if, for example, in this case, we have the wrong number of columns. So as you write it, you'd have all these different errors in. And the reason you put them in is to make your life easier, so that when the error happens, it gives you a descriptive error, basically telling you that you've got the wrong number of rows. So what we want to do then here is call array copy. So call array copy row, and the destination array. So it's basically just these things here. This is the destination array, and the destination row is output row. The source array is sales, obviously, and the source row is I. And then we just space R and just pull this over here. And let's change Mary to Jenny this time. And then run the code and you see that it worked fine. So you can see this code is much neater. And for what it's doing is like not really that many lines of code. And as I said, we can, every time you write this, you can just start with this code, get the data, and this code write out the data. If you're looking for a way to organize your VBA code correctly, then make sure to check out this video on how to design and code your VBA application.